Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 25, 2025, about a week ago. It introduces a long video reasoning framework that interleaves tool calls with chain of thought, letting models actively crop and resample video segments, which boosts performance by about 6 points over the next best open source model and comes within about 4 points of GPT-4o on average. The paper is titled LongVT, Incentivizing Thinking with Long Videos via Native Tool Calling. And as we will see later, this approach to letting models search through time has some really exciting implications for how we handle long cluttered videos. Also, the authors shared a full LongVT implementation on GitHub. You'll find the training pipelines for SFT, RL, and RFT, evaluation tasks for long video benchmarks, and a complete data pipeline for segmenting, captioning, and generating QA from videos, plus example scripts to reproduce their results and train your own models. On Hugging Face, you'll find 8 billion parameter LongVT SFT, RFT, and RL checkpoints, plus scripts showing how to run long video question answering with native video cropping tools. Figure 1 contrasts how a model that can crop and revisit video segments reasons much more effectively about a long soccer match than one using text chain of thought alone. The top film strip summarizes the very long match, where the key volley appears only briefly. On the left, the text-only chain of thought stays stuck because the crucial frames were never sampled. On the right, the interleave tool calls let the model zoom into promising moments, correct its mistakes, and finally ground the answer in the exact scoring clip. So while Figure 1 contrasted different reasoning styles, Figure 2 shows how the video SIAH pipeline manufactures the training data that LongVT needs. The flow diagram traces a long video as it gets sliced into scenes, captioned, and turned into segment in a haystack questions, which are questions about very brief but decisive moments. Several large multimodal models caption clips, propose questions, and then filter out bad ones, while humans spot recurring failure patterns. The final branch generates interleaved tool call traces that teach the model how to crop videos and ground its answers in precise moments. Table 1 spells out how much training data backs this whole pipeline, which matters because long video reasoning needs lots of diverse supervision. The non-tool supervised fine-tuning split holds about 229,000 chain of thought samples focused on video and image reasoning. The supervised fine-tuning with tools adds around 19,000 cases distilled from stronger models using multimodal chain of tool thought, meaning traces that mix reasoning text with explicit crop calls. Finally, roughly 17,000 examples support reinforcement learning and reinforcement fine-tuning, so the agent can practice long video question answering with feedback and then distill its best behaviors. Alright, Figure 4 shows how the full LongVT agent actually thinks its way through a 1-hour video. The top film strip illustrates a global skim that spots rough moments of interest, then crops tighter clips at several timestamps to check details and revise the guess. The lower pipeline diagram explains interleaved multimodal chain of tool thought, which means the model alternates reasoning text with explicit crop video calls. A reward manager then scores each trajectory on answer correctness, formatting, and how precisely those crops match the true evidence in time, so the policy gradually learns human-like hypothesis and verification behavior. Table 2 shows that LongVT consistently outperforms other open-source video models on long video benchmarks. The top block contrasts proprietary systems, where Gemini and GPT-4o still lead overall but by only a few points. The middle section reports sparse frame sampling results, and LongVT with reinforcement learning already edges out prior open models. The bottom dense sampling section is strongest, where LongVT with reinforcement learning and reinforcement fine-tuning reaches the best open-source average score and narrows the gap to proprietary models. Table 3 explains what actually makes LongVT work in practice. The top block shows that self-curated multimodal chain of tool thought traces and self-curated question-answer pairs both give several point gains, so fine-grained supervision really matters for long videos. The middle block shows that stacking supervised fine-tuning, reinforcement learning, and reinforcement fine-tuning yields the best scores because each stage adds complementary skills. The bottom block compares temporal rewards and finds that the intersection over union reward, which measures how closely a predicted time span overlaps the true span, gives the most accurate localization. So the big takeaway is that letting models actively crop and revisit segments instead of passively reading sparse frames really unlocks long video reasoning and sharply cuts hallucinations. More broadly, This suggests future multimodal systems will need search-like tools over time, not just bigger networks. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.